Hi everybody, I'm Timo. As I said, I live close to the Dutch border, so it was like 1 hour, 20 minutes to come here. I have and work for a company called GiantSwarm, and yeah, I want to give you a little bit insights of what we do and why we're doing this, and yeah, telling you about the motivation. We manage Kubernetes clusters in our own data center and also at customer data centers 24/7. So we are on call. We are not only installing it and then giving it over to the corporate IT, but we are also maintaining it, running it, and are fully responsible for it. And who of you has experience with Kubernetes? Who's running Kubernetes? Okay, cool. Because I'm not explaining Kubernetes here. I'm maybe touching it, but I'm telling you a little bit more about the concepts. And I hope this is, without deep knowledge of Kubernetes, is still understandable. So we have our own data center in Frankfurt. Yeah, I live close to the Dutch border, so Kubernetes as a service is KaaS, is like cheese in the Netherlands. And so that's what we started with, having our own data center and having like a Kubernetes as a service. So you just sign up and you get your Kubernetes, and that's what we do. And while building this, and we were building this like in the very beginning, we did this on AWS, but we switched to bare metal quite soon. And since we were doing this on bare metal, a lot of companies ask us if we can do this in their own data centers, because they want to have Kubernetes not only on AWS, but they also want to have it inside. And yeah, it happened to be that we're not only running multiple Kubernetes clusters in our own data center, but also the customers wanted to have multiple Kubernetes clusters, not only one. And why is that? I mean, there's soft multi-tenancy in Kubernetes, so you can isolate the workloads in Kubernetes through network policies. You have role-based access, where you can define which kind of user of the API is allowed to do certain things, but still it's a soft multi-tenancy, and in a corporate environment, this is sometimes not what security wants. And so there are like different applications. Some of them deal with financial data, some with privacy data, and they are not allowed to run next to other workloads that are maybe just for testing, or so you end up having, for multiple reasons, having multiple Kubernetes clusters in one data center. So being it a team wants to test out a new Kubernetes version, to test the Jenkins build pipeline, if it still works with the new version, or be it the separation of like the development, test, pre-prod, prod environments. And so that really depends on what the customer wants and what the demands from security are, and how far they are or how much trust they have into the new technology. And yeah, what we strongly believe is that people must come to their own must come to things in their own time, in their own way, for their own reasons, or they never truly come at all. That means they need to learn how those environments work, and how things change if you have such a dynamic infrastructure, and lots of processes in those companies are not prepared for that at the moment. And that's why we encourage to use the soft multi-tenancy features. So we enable role-based access. We tell them how to use network policies to separate their services. But and there are good reasons for that, because it doesn't make sense to have a small cluster for each and every small thing. So you end up having like 3 machines running a Kubernetes cluster for every single app. That doesn't make any sense, right? You want to have a big cluster, and you want to have as much workload on the big cluster as possible. And but still, those processes and the understanding of the new technology has to grow. And that's why we say, okay, you can do this in the beginning. You can have like small clusters, but you need to learn how to deal with that and have like new guidelines from security that allow certain things that, you know, like an overlay network between zones is sometimes not allowed, because there should be like a static firewall in between that is like kind of like manually configured or statically configured, and this is going to change if you have such an environment as Kubernetes, who brings a lot of those things as a software API, and you can just dynamically change that. So yeah, internally our product is called GiantSwarm because we're using a Kubernetes to create those smaller Kubernetes, or to create the guest Kubernetes clusters. And so yeah, the motivation for us is rather obvious. We're providing Kubernetes for our customers, and actually we know why. So we would like to use it as well, and not. And I'm just, you know, that's just a placeholder. I don't want to do it with Ansible anymore, right? So that didn't make any sense for us anymore. So we have reasons why we think Kubernetes is a good way to run distributed applications, and Kubernetes itself is a distributed application, so why not using Kubernetes to actually deploy Kubernetes? And it's sometimes a little bit confusing if it's like the host cluster or the guest cluster. So this is like on the diagrams I'm showing the definition. G8 is the GiantSwarm, and K8 is the Kubernetes. GiantSwarm is the outer one, the host cluster, and the guest cluster is Kubernetes. And please don't confuse this with Kubernetes. That's how the people from the US are mostly pronouncing it. So that's a restaurant in somewhere in around New York or so. Anyway, so architecture. As with like lots of those container management platforms, we usually have a control plane, which is like the management zone where the infrastructure management is happening. And then on the other side, we have an application zone, or actually there can be multiple zones, and you can have like this typical 3-layer. So you have like presentation, application, and data, or business logic, or whatever you want to have in terms of networking zones or application zones. And in the control plane, or with the control plane, we usually have 3 like main roles talking to it. So that's us. We are the GiantSwarm admins. Then there's a cluster admin, which means somebody who's able to create a new cluster, to manage a cluster, to create accounts for people who want to use the cluster. And then, yeah, you have the people that are using the cluster, speaking to the Kubernetes APIs. And in the control plane, we run the masters, and then the application zone is where the nodes are running of the guest clusters. And within the GiantSwarm API, there are a couple of services. I'm not going into detail there. In infrastructure service, there are mostly there's like the storage services. We use Vault for secrets. We're using software-defined networking. Those kind of tools are in infrastructure services, and then we have monitoring where we have like Prometheus and logging, so Elasticsearch and such things running. And and obviously in the application zone there are then the agents that collect the data or forward the logs and stuff like that. So if you zoom out a little bit, it would look like this. As I said, I'm not going into like detail. So there are like lots of services around the API and monitoring infrastructure services. Then on the other side, you see the nodes. And maybe to make it like to go a little bit deeper into it, I'm going to show you how we set up the networking between the VMs, because we isolate the Kubernetes clusters through an overlay network. In this case, we're using the XLAN backend from Flannel, and it looks like this. So there are two physical nodes. On those nodes, we run VMs, and those VMs are connected together through Flannel. And Flannel has this concept of a Flannel server and Flannel client, so you can run multiple Flannel clients per physical machine. And what the Flannel client does is allocate a subnet for the VM on that local host and communicates to the other Flannel clients running on another machine that this subnet is over here, and if somebody wants to send traffic from the other machine, it needs to be sent to this machine. So that's roughly how it works. And for the VMs, we're using containers to start the VMs. That always sounds weird for people, but it's just on a CoreOS. Most of the time we're running on CoreOS, and we don't have any tooling around VMs. So we need to ship the tools, right? And they come in a container, right? Then we have Chemo in the container, and in the container we can start the Chemo process, which actually launches a KVM in a container. But it doesn't really, there's like no overhead that we are doing this in a container or not. It's just that it ships the current version of our VM tooling. And and we're parameterizing the cloud configs for the nodes, so that node actually knows to which cluster it belongs and stuff like that. And we also do a couple of things outside of the VM that, for instance, issuing the certificates. This is happening outside of the VM, and then the certificates are mounted into the VM that are necessary for all the Kubernetes services to speak to each other. And in the masters, we are then launching a couple of, so we are launching obviously the API services, scheduler and such things, but we also launch Ingress, which is, in our case, it's an Nginx that is dynamically configured to receive external traffic and redirect the traffic to the right pods, which is the containers where your services are running. And we also install kubedns, so you have DNS functionality within your cluster. And to enable the network policies, we run Calico inside of the Kubernetes clusters. So Calico is another network tool, and they were the first who started with the network policies, and you can define those network policies in the Kubernetes API, and then the Calico policy control takes care of actually implementing those rules. And on the other side, on the nodes, actually the Ingress controller that is started in the master is then launched on the nodes. Because if you go back to the image here, you can see that we have separated incoming. So if you think of like above, there's like the internets and then like talking to this kind of stack, then this is like incoming traffic is separated here from where the applications are. So you can actually have this and the access to the cluster management and stuff like that inside your VPN and not accessible from the outside, but you can have traffic coming in to the application zone. And so that's why the definition of the Ingress controller is launched in the master here, but actually those Nginx need to run there on the other side. maybe in your presentation zone. And most of the time in integration with the load balancer is that it just checks on a certain port if there's a response, and then it knows, okay, Ingress is running here, so I'm sending traffic over there. And another thing is that we have Vault for certificates, so we create a root CA per cluster, and then create a bunch of roles in a Vault that allow you to issue certificates for the specific services. So for instance, a lot of services in Kubernetes have mutual TLS. So, for instance, etcd or the Kubernetes API, you both need a server certificate and a client certificate to let those either machine-to-machine communication or human-to-machine communication needs to have certificates. And so to have those in a dynamic way, we are using HashiCorp's Vault, which supports a PKI backend. In that case, actually, if you create a root CA, the key is kept inside Vault and will never leave Vault. And that's the current setup we're using. And but then we are able to ship the certificates to the nodes and actually rotate them every 3 days at the moment. So it's not that you issue a certificate and then it lives for like 1 year or 2 years. It's actually, if you automate it and it works, you can do it faster, right? We can discuss if that makes sense for you or not. I'm happy I'm here today. Yeah. We had a couple of iterations to come to that point where we're actually using Kubernetes to launch those clusters. So in the beginning, so we created like our own kind of orchestration a couple of years ago on top of Fleet. So we were always using CoreOS, and in the beginning there was like a very low-level scheduler called Fleet that was like a distributed way of launching systemd services. So we used that in the beginning. We actually also implemented a new engine in Fleet because it was not that scalable, but yeah. Kubernetes had great traction. We were in the community anyway, or very, very close. And so at some point we said like it doesn't make sense anymore to do our own thing that looks similar to Kubernetes. We just want to use Kubernetes. And but in the beginning, when we started with providing Kubernetes for our customers, we still had Fleet underneath to actually launch those clusters. And then we moved to the next step where we had like already Kubernetes manifests, but they were kind of like templated. So we had like just changing some configuration, some manifests, and then starting a cluster. That was like the second approach we did. And after that, we realized we want to write code to actually do this. And I think around October or so, CoreOS launched this blog post that they are actually building custom controllers for Kubernetes, but they're calling them operators because operators, yeah, that are usually humans, but this is now code, and but does a similar thing. It just automates things in the cluster that have been done manually before. So we like this term a lot because it actually coins it way better than a custom controller. Yeah, that's when we started writing our own operators to actually automate all this inside of Kubernetes. So, and that's what I want to explain to you a little bit more. So yeah, what I just explained, and I rushed through this like different steps of creating VMs and certificates and those kind of things. This is all something, yeah, we kind of have done before manually or had some automation for it. And now we're trying to write Go code that lives inside the cluster all the time and does the same thing. And why is this interesting, or why is this concept interesting? So there's this concept in Kubernetes called third-party resources that let you extend the API of Kubernetes. And the best way to understand this is, if you think of the Kubernetes API server, it's just a RESTful API that does CRUD. So you can actually create an object, retrieve an object, update an object, you can delete it. Nothing more. It's just like a key value store. You just put something in, and you know, and there are like some concepts around this. So there are manifests and then definition of those building blocks, or of those of the schema of certain things that come with Kubernetes. So for instance, a pod that's defined, it has certain attributes. You cannot write what you want into the API. So it's validated and those kind of things. But there's also something called third-party resources, which lets you create your own schema. Your own, and the resource is actually like the schema, the definition. You can think of it like your class or your database table. And then you can create third-party objects inside of this schema. So for instance, you want to have like multiple shops on Kubernetes, then you define your own third-party resource shop, or Magento, or whatever. And then it has certain attributes like, I don't know, color, or URL, name of the shop, those kind of things, and you add those. And then you create your shop operator that watches the API if somebody created a new shop. And if the shop operator realizes, there's a new definition of a shop, it actually launches the containers and gives the right parameters that were in the third-party object to create this shop instance. And that's the same thing we did for Kubernetes clusters itself. So what we have right now is a KVM operator. That's slightly what I described before. So we're launching pods that actually start KVM instances, and but we're also working on an AWS operator. So very similar, but we're not using KVM on AWS. We're actually using the EC2 API. So we start EC2 instances that then form a cluster. Just to understand it a little bit more, I want to go through this step by step. So if you create a guest cluster, and on the right side you can see like some kubectl commands. So actually, listing pods, listing namespaces, listing secrets, and there's like the third-party objects. So if somebody creates a cluster, it goes through like our API gateway, all the services that we have, and in the end there's like Kubernetes D. That's a service from us. That's our layer to Kubernetes that writes a third-party object inside the GiantSwarm API, which is just the standard Kubernetes API. That's our underlying Kubernetes. And when this happens, we already create a namespace for a new cluster. And then down there you can see that we have a cluster TPO now, we have a CA TPO, and multiple TPOs for different certificate roles. And then an operator is watching the TPO. For instance, the CA operator is watching the CA TPOs, and then it knows, okay, I need to create a new cluster. I need to mount the PKI backend in Vault. I need to create a root CA. I need to define the roles, and this is done by the CA operator. On the other side, the third operator then knows, okay, I need to create some certificates in Vault for the actual services. The reason why we separated this is the different privileges you need to actually set up the PKI infrastructure, and on the other side, just issuing the certificates, and also both of them have like a different life cycle. So the root CA stays way longer than, for instance, the certificates. That's why we said at one point it makes sense to have like separate operators for that, and not having all the stuff in one operator. Obviously, we started with one operator. The KVM operator had everything inside in the beginning, but at some point we just split it up because it makes more sense to have like smaller operators. And the KVM operator then creates replica sets that actually create the masters and the workers, and also the Flannel configuration. So yeah, I have to hurry a little bit. So I basically said this, in the cluster TPR, you can configure the parameters of the cluster. For instance, this is like the Kubernetes configuration, the version, stuff like that. Maybe some ingress definition, the Flannel configuration, and certain parameters you can give to masters and nodes. And yeah, and the same is for like CA and cert TPR. They have certain attributes like TTL, the number of roles, or actually the defined roles, which domains are allowed within that cluster, so that in the end the cert TPR knows like what kind of common name can I issue a certificate for. What kind of alternative names do I have to put into the certificates? Those things. And yeah, I have a small demo, if it works, you know. So yeah, it's a little bit hard to read. So here, that's our web interface, and so I'm currently here in the DevOps gathering organization. I can create a new cluster. Yeah, I just want to have like two nodes, and you can change configuration here, and then you can actually create the cluster. And yeah, while your cluster is created, you can already start creating key pairs. So now I'm creating a key pair. This one is now here by default 1 year. As a user, I want to access this Kubernetes instance, and then the web interface gives you or not, gives you the configuration you can put into your kubeconfig. So you can configure your kubectl using this configuration to actually access the cluster. And on the other hand, you can go, and this is that's the outer cluster right now. So I can say get namespaces, and then I will see what was the cluster, K16KK. Yeah, there it is, active since 1 minute. And yeah, you can also you can also query the clusters. Kubectl. Typing and looking is bad. I actually can open a session here, so that's better. Yeah. Kubectl get clusters, and that's the TPR we created. And then you find the clusters that are currently defined in this environment. And there also is the K16KK cluster. Yeah. Yes. And Yeah, what's coming next? What we realized, and I already explained that a little bit, is like micro operators are actually useful. Creating smaller operators and not mixing up too many different life cycles, different workloads into one operator makes sense. To have one thing that has one responsibility, it's easier to change. It's easier to replace those. I mean, you probably heard this a lot of times with microservices. So it's the same thing. For that, we realized that with every operator we write, we have some boilerplate and some stuff you always have to do if you write an operator. So we want to create Operatorkit. We're using MicroKit for our microservices, which is like our putting together some Go tools we like and we usually use in our services. And we want to do the same thing for operators, just putting all the boilerplate into one library that you can leverage to write more operators. And the next big challenge is definitely making GiantSwarm, the outer Kubernetes, self-hosted. Because we still have this chicken egg problem. How do we set up the first Kubernetes, right? And so the community is going into the direction that a Kubernetes should actually host itself. So you can do a rolling update of your own Kubernetes, and but for that, all the Kubernetes components need to run inside of Kubernetes. So there needs to be a way to set up Kubernetes and then contain its own components. And this is kind of important because that would also mean that you could have something like a Kubernetes operator running in each of the Kuberneteses and doing all the jobs of like upgrading a Kubernetes instance, going into maintenance, taking out a node. Those things always contain multiple steps, and you can codify those steps into an operator, and then you actually can maintain a Kubernetes cluster way easier. And that's it. Thank you very much.